Alright, hello everyone, welcome back to another video. Today we'll be doing exercise 2b. Alright, 2b is just on functions again. We'll start with 1a1. One is asking us for each of these quadratic equations, determine the equation of the axis of symmetry, the vertex and its concavity, domain, and range. First equation is y equals x squared plus 6x plus 8. Okay. We first need to actually write this in a vertex form. Vertex form, remember, is written like this, where A is our transformation, and H and K are the X and Y value of the vertex, respectively. To determine this, we're first going to split this quadratic equation like this, since we want to get, that's supposed to be squared. This value here. This comes down, and to get x squared plus 6x with a remainder, that's going to be x plus 3 squared, which is equal to x squared plus 6x plus 9. However, we need to get we need to get an 8 from this equation. And to do that, we can simply just subtract 1 from this entire thing. So that means this will give us our x plus 3 squared. And to get that 8, we just minus 1. And asks us about the equation of the axis of the symmetry. Yeah, the equation of the axis of symmetry. Okay, remember the equation of the axis of symmetry is just given by the x value of the vertex. In this case, the x value is negative 3. The reason it's negative is because originally our h value started as negative, so we put a negative in there, it's going to be positive. Number 2 asks us the equation of the vertex, which is going to be the x value, and then the k value, which is negative 1 here, or the y value. Okay, and 3 is staring to its 3 wants its domain, range, and concavity. Since this is a positive function, it's going to be concaving up. Its domain is just going to be equal to all real numbers, and its range is just going to be from well, we need to actually look back here to find out what it is. For any usual quadratic, your domain is going to be basically just all real numbers if it's set like this, or all real positive numbers, since whatever we plug x in here, even if it's negative, it's going to turn out positive. But since we have a negative 1 on the outside, that means our lowest number that we can go to is going to be negative 1, which is going to be less than or equal to, oh, not like that. How should I even state this? Okay, so y is going to be less than or equal to infinity, which is going to be greater than or equal to negative 1. Alright. On to the next one, we have 1b. The quadratic here for this one is y is equal to 10 plus 3x minus x squared. Okay, we're going to rewrite this as y is equal to negative x squared plus 3x plus 10. And the axis of symmetry, we're going to basically do what we did last time. I guess there's another way you could do it. It's by using x is equal to negative b divided by 2a to find the x value for the axis of symmetry. I don't know if that's what they want you to do, or if we're allowed to do that. I'm assuming you would be, but I'm just gonna assume not for now, just in case. Alright. Here we're gonna take the negative out of this entire equation so we can get our a value out of there. Remember, we had an a value last time, which is just a transformation. This is going to transform it downwards now. So let's split this equation up. So now we have x squared minus 3x. To get x squared minus 3x from any quadratic, you need x minus 3 divided by 2 squared, which in turn is going to be equal to x squared minus 3x plus 9 over 4. However, we need to get a negative 10 from this. Did I do this right? Yeah. Yeah, okay. We need to get a negative 10 from this. So let's first start by subtracting the 9 out of 4 out of here. So we'll do minus 9 out of 4 here. And that takes away our original 9 out of 4 from here. But now we need to make it negative 10. So we do a minus 10. And this is going to be equal to what is this equal to actually? I can't think of it on the top of my head. Minus 10 fraction form. Negative 49 over 9. Okay. So then we're left with x minus 3 over 2 squared minus, oh no, it's plus, well, it's a negative number, so it's going to become plus, or minus 49 over 4 and we can't forget this. Let me double check everything. Oh wait, I went too far. Oh wait, no, now I see it. Okay. So we do have an issue. Issue is that this needs to become a positive eventually, but this negative doesn't go to it, so this is a positive. Okay, got it. Which means that our x value for the axis of symmetry is going to be negative 3 over 2. Or just 3 over 2, sorry. Almost forgot that. Our vertex is going to be the x value of our axis of symmetry, well, the equation, and our k value out here, 49 divided by 4. Okay, and let's start with our concavity. Since it is a negative function, where it's a negative x squared, that means it's going to be a down concavity. Domain is going to be equal to all real numbers. And our range, as we said, is just going to be our leftover here. So it's going to be all real numbers such that y is less or greater than or equal to 49 divided by 4. Whoa, almost just made a mistake there. It's going to be less than 49 divided by 4 since there is a negative out here. Okay. On to 1c, we have y is equal to 3x squared minus 12x minus 5. Okay. First things first is we're going to take the 3 out of this equation to get x squared minus 4x minus 5 over 4. Oh, whoa, oh my god. 5 over 3. That's, okay. Okay, now we're going to separate this equation. X squared minus 4x, get that from a quadratic here, is going to be x minus 2 squared. Issue is that equals x squared minus 4x plus 4. So in our equation, we're going to have to get rid of that 4 and get a negative 5 over 3. So we're going to do we're going to rewrite it like x like this. Minus 4 minus 5 over 3. And this in turn is going to be equal to x minus 2 squared minus, I don't even know what that equals. Okay, just give me a second. Get 4 minus 5 over 3. Okay, fraction. Jeez, why isn't it? Okay, minus 17 over 3. And we're going to do a big parenthesis on this because this 3 follows down here, our a value originally. And that's what I messed up on B. Okay, that's why I originally got a, what is it called, negative here. But yeah, our 3 value is on the outside of all this. So then we'll get 3 x minus 2 squared minus 17. And that's what is our y is equal to. 1 asks for our equation for our line of symmetry. It's just going to be x equals 2. And then 2 is going to come down here. Negative 17 is going to be our y value for our vertex. And since it is a positive function, or positive a value, it's going to be an up concave for our domain being equal to all real numbers. Our range being equal to all real numbers, such that looks like our lowest value that it can be is negative 17. Y is greater than, y is greater than or equal to negative 17. Okay, 1D. We have the equation y is equal to, where'd it go? 7 minus 4x minus 2x squared. We're going to take the negative 2 out from this entire thing so we can get x squared. So we'll have negative 2 x squared plus 2x and minus 7 over 2. We're going to separate this like that. And this equation stems from x plus 1 squared, which is equal to x squared plus 2x plus 1. To get the plus 1 out of there and then get a negative 7 divided by 2, we're going to do minus 1 minus 7 divided by 2. And that simplifies to negative 9 over 2. And don't forget, this is all in brackets with the 2 coming back here. This means that we'll end up getting y is equal to negative 2 x plus 1 squared plus 9. And 1 is asking us for the equation. Remember, your axis of symmetry is just going to be your h value, which in this case is negative 1. The 2 is going to be equal to negative 1 and 9. And 3 it's going to be concave down since it is a negative a value. Domain is going to be equal to all real numbers. Range is also going to be equal to all real numbers such that y is less than or equal to, since this is a negative function, it has to be less than or equal to 9. Okay, on to 2. I probably should have took a picture before starting here, but 2 asks us to use the information shown in each graph to write the equation of the quadratic function it represents. Select the most appropriate form for finding its function. Okay, simple. Since these are all quadratics, I can probably draw them out for you all. We're going to be like this. Okay. It gives us 2 points. It gives us this point right here, which is equal to 0, negative 12. And it gives us its vertex, which is going to be 2, negative 16. Since it gives us its vertex, I said the most appropriate form to find its equation is going to be in vertex form. So let's go ahead and write it like this. We know that h in this case is going to be equal to negative 2 and k, or 2, and k is going to be equal to 16, so we can rewrite it like this. And it gives us that when x is equal to 0, y is equal to negative 12. So let's plug those in. I meant to do an equal sign there. Negative 12 is going to be equal to a. That's supposed to be a square. I keep forgetting that. Minus 2 squared minus 16. Negative 12 is equal to 4a plus 16. Doing simplification, we got that a is equal to 1. That means our equation is going to be y is equal to 1, which you don't have to write, times x minus 2 squared minus 16. Okay, on to 2b. This time we have a concave down function, so we know our a value is going to be negative. It gives us the points negative 3, 0. Okay, this isn't very accurate, but it also gives us, this isn't the vertex, by the way, this is not the vertex. It gives us the point 0, 3, and 1, 0. Okay, it seems the most appropriate form to write this in is going to be factorization form, in my opinion. We know that when x is equal to negative 3, that means y is equal to 0. So we can set this as x plus 3 times, and when x is equal to 1, y is equal to 0, so x minus 1. And I don't know if they actually want you to simplify this. Yeah, they definitely do. Okay. So we'll have y is equal to x squared. Oh my god. Maybe I should have wrote this in a different form. X squared plus 2x minus 3. But we're not done yet. It says that when x is equal to 0, y is equal to 3. The issue is when x is equal to 0 here, y is not in fact equal to 3. It's going to be equal to negative 3, so that tells me that we need to multiply this entire thing by negative 1, and it makes sense because our a value needs to be less than, or negative 1 or less than, negative number for this equation to, look true. So that means we'll get negative x squared minus 2x plus 3, and that is our answer. To C. Sorry if my voice is a bit odd today, by the way. I just went to the dentist and I'm still numb and that feels weird. Okay. Over here, we have the points 1, 0, 5, 0, and then it gives us the point 4, negative 12. Okay. Once again, we're going to write this in factorized form. When x equals 1, y equals 0. And when x equals 5, y equals 0. I'm going to put an a out here and solve it a different way. So we're going to plug this into here now. So negative 12 is going to be equal to 4 minus 1. 4 minus 5 times a. And a is just going to be basically our transformation that it's doing so we can actually fulfill this request here. So you have negative 12 is equal to 3 times negative 1. So negative 3a. That means a is equal to 4. Right? Yes. Okay. That means that going back here, we can write this equation as y is equal to 4 times x minus 1, x minus 5. Simplifying this out, we get x squared minus 6x plus 5, and that's getting multiplied by 4. So our final equation is going to be y is equal to 4x squared minus 24x plus 20. 2D. Okay, this is another positive function. This time it gives us 2 points only. It's going to be 4 and 6, and it gives us our vertex, so that already tells me that this is going to be best be written in vertex form. Remember our vertex form equation, where h is our x value and k is our y value. And now we're going to plug this equation back, or these two coordinates back in here. So 6 is equal to a times, I keep forgetting to put this square, 4 minus 2 squared minus 6, plus 6 on both sides. 12 is equal to 2a, a is equal to 6. So that means our final equation is going to be sorry, give me a second. Huh. Where'd it go wrong? Hold up. We have 6 is equal to 2a. Oh, that is weird. Minus 6. Yeah, okay. A is equal to 6 then. Right? I don't know why I'm asking y'all. Oh, wait, what am I doing? Oh my god, embarrassing. Yeah, plus 6 on both sides. Negative 2 squared is 4. Okay, a is equal to 3. That leaves our final equation as 3x minus 2 squared minus 6. Jeez. Okay, on to our next graph. I honestly thought it ended at D, so I was kind of excited. 2e. We're given this chunky function where we have negative 5, 0, a random point of 1, 3, and our final y-intercept or x-intercept of 2, 0. So once again, we're going to write this in factored form, x minus 2, x plus 5. We're going to plug in these coordinates back in to get 3 is equal to 1 minus 2, 1 plus 5, a. So 3 is going to be equal to negative 6a. A is going to be equal to negative 1 over 2. Which means that y is equal to negative 1 over 2 times this whole thing simplified. This is equal to x squared plus 3x minus 10. Which means that y is equal to negative 1/2 x squared minus 3/2 x squared plus 5. I just meant 3/2 x, not x squared. Okay, f. We're giving a skinny little function over here. That's not how it looks. Okay. So we're given 2 points this time, so it's going to be a vertex one where it gives us negative 5. 45 is the random point, and the vertex as negative 10, 60. Which means that y is going to be equal to a. Now I can already assume that a is going to end up being negative. Ax plus 10 squared plus 60. Plug these points in. 45 is equal to a negative 5 plus 10 squared plus 60. Negative 15 is equal to 25a. A is equal to negative 15 divided by 25, which is what, like 3/5. So that means our final equation is going to look like this. Negative 3 over 5 x plus 10 squared plus 60. Alright, well, I hope you all enjoyed today's video, and I will see you all next time. I might skip over to exercise like 7C, or just exercises in unit 7 for a bit, because I need to do my math homework, and this could be my excuse to do it. So have a good day.